Hello there, and welcome to the Sleepy Whisper. It's wonderful to have you here tonight. The ocean is perhaps the most mysterious and soothing place on our planet, stretching endlessly beyond horizons, holding depths we've barely begun to explore, and breathing with rhythms that have lulled countless souls to sleep for millennia. Some waves have traveled thousands of miles just to whisper against the shore. Some creatures in the deep ocean create their own light in worlds that have never seen the sun. And beneath the surface, currents carry warmth and life across entire continents, connecting every drop of water on Earth in one vast, gentle circulation. The sea covers more than 70% of our planet's surface, yet we know less about its depths than we do about the surface of Mars. In its darkest trenches, mountains taller than Everest rise from the seafloor. In its warmest shallows, gardens of coral house more colors than any rainbow. And everywhere between, life flows in patterns so ancient and so perfect that they seem like music made visible. The ocean holds 99% of all living space on Earth, creating room for creatures we have never imagined and supporting ecosystems more complex than any terrestrial environment. Tonight, we'll drift through 100 fascinating truths about the ocean, letting each fact carry us deeper into calm. If you enjoy these gentle journeys, consider liking and subscribing, or share some thoughts in the comments. It helps others find their way here too, one sleepy soul at a time. But for now, you don't need to do anything at all. Just let your breathing slow to match the rhythm of distant waves. Let your body sink into comfort like a pebble settling onto soft sand. Imagine the gentle sound of water lapping against the shore, endless and peaceful. Picture yourself floating weightlessly in warm, crystal clear water, supported by the ocean's ancient embrace. Now, if you're ready, let's begin our journey into the calming mysteries of the sea. The ocean's gentle breathing. The ocean breathes in rhythms older than memory. Every wave that touches the shore is part of a cycle that connects all water on Earth. When a wave breaks on a beach in California, it might have begun as a whisper of wind thousands of miles away in the middle of the Pacific. The water itself has been traveling for weeks, gathering energy from storms and gentle breezes alike, carrying that motion across vast distances until it finally exhales against the sand with a soft sigh. This breathing never stops. Even on the calmest days, when the surface looks like polished glass, the ocean continues its subtle rise and fall. Tides pull and push according to the moon's gentle influence, creating a heartbeat that every coastal creature knows by instinct. The rhythm is so consistent, so reliable, that it has become the Earth's own lullaby, playing softly at the edges of every continent. The sound frequency of waves breaking on shore matches the brainwave patterns associated with deep sleep, which explains why millions of people find ocean sounds so naturally soothing. Scientists who study these patterns have found that ocean waves follow mathematical principles as precise as music. Each wave builds on the energy of those that came before, creating harmonies in motion that repeat across time and space. The spacing between waves, their height, and their speed all follow predictable patterns that create the rhythmic breathing we hear on shore. To listen to waves is to hear the planet itself breathing, a sound that has comforted living creatures since the very first life emerged from these same waters billions of years ago. Hidden depths of perpetual darkness in the deepest parts of the ocean, night never ends. More than a mile below the surface, sunlight has never penetrated. Here, in the abyssal depths, the pressure is so intense it would crush any surface creature instantly. Yet life thrives in ways that seem almost magical. These deep waters remain at near freezing temperatures year-round, creating vast underwater deserts of darkness where time moves differently. The water is so still in some deep ocean areas that it takes thousands of years for currents to carry a single water molecule from the surface to the seafloor and back again. The deepest point on Earth, the Challenger deep in the Mariana Trench, plunges down over 36,000 feet below sea level. If Mount Everest were placed at the bottom, its peak would still be more than a mile underwater. In these profound depths, the water moves with currents so slow and steady they create a kind of liquid meditation, flowing in patterns that have remained unchanged for thousands of years. The pressure at these depths is more than 1,000 times greater than at sea level, equivalent to having 50 jumbo jets pressing down on every square meter of surface. Yet, even in this eternal darkness, life persists. Creatures have evolved to create their own light through bioluminescence, turning the deep ocean into a galaxy of living stars. Their gentle glow flickers and pulses in the darkness like distant streetlights in a peaceful neighborhood, creating one of the most serene light shows in the natural world. These deep-sea dwellers move with a dreamlike slowness, conserving energy in their cold, dark world. Many deep-sea fish have metabolisms so slow that they might live for centuries, growing imperceptibly in the timeless depths where seasons and day-night cycles have no meaning. The ocean's memory of ancient rains. Every drop of water in the ocean carries stories from the past. The water molecules surrounding us today have been part of clouds that rained on dinosaurs, filled the rivers that ancient civilizations depended on, and cycled through countless forms over millions of years. The ocean is Earth's greatest library, holding these memories in its vast blue depths. Water molecules are virtually indestructible, recycling endlessly through evaporation, condensation, and precipitation in a cycle that has continued unbroken for billions of years. Some of the water in today's oceans fell as rain during the planet's earliest years, when the atmosphere was still forming and the surface was cooling from molten rock. This water has witnessed the rise of the first life forms, the movement of continents, and the slow dance of evolution that brought forth every creature that has ever lived. In a very real sense, the ocean contains the liquid history of our world. Scientists can trace the journey of water molecules through different reservoirs, the atmosphere, rivers, groundwater, and ice, each leaving subtle chemical signatures that tell the story of Earth's climate history. The salt dissolved in seawater comes from rocks worn down over eons, minerals carried by rivers and rain into the sea. Each grain of salt represents countless years of patient erosion, mountains slowly surrendering their substance to the water's gentle but persistent touch. This is why the ocean tastes of time itself, holding the essence of every landscape it has ever touched. The ocean's salinity has remained remarkably constant over hundreds of millions of years, maintained by the perfect balance between salt input from rivers and salt removal through various geological processes. Creatures that glow in the dark in the ocean's depths. Many creatures carry their own light. Bioluminescence is one of the most common traits in deep-sea life, with thousands of species producing their own gentle glow through chemical reactions inside their bodies. These living lights create patterns of beauty that rival any constellation, flickering and dancing in the eternal darkness like underwater aurora. More than 80% of deep-sea creatures produce their own light, making bioluminescence one of the most widespread adaptations in the ocean's depths. Jellyfish pulse with rings of light that ripple across their transparent bodies like gentle heartbeats made visible. Deep-sea fish carry rows of lights along their sides that twinkle like holiday decorations. Even microscopic plankton can light up when disturbed, turning breaking waves into streams of liquid starlight. This bioluminescence serves many purposes, from attracting mates to confusing predators. But to human eyes, it simply looks like magic. The chemical reaction that creates this light is incredibly efficient, producing almost no heat and wasting virtually no energy as unwanted warmth. The light produced by these creatures is typically blue or green, colors that travel farthest through water. This creates an underwater world painted in the most soothing hues imaginable, a realm where gentle blues and soft greens pulse and flow in patterns that seem designed to calm the mind. Scientists studying these creatures often describe their work as meditation, watching these living lights drift through the darkness with hypnotic grace. Some deep-sea jellyfish creates light shows so complex and beautiful that researchers have compared them to living fireworks displays, with cascading patterns of light that flow across their bodies in waves of blue and green luminescence. The sea's infinite recycling system. The ocean is the world's greatest recycling system, constantly cleaning and renewing itself through processes that have operated unchanged for millions of years. Water evaporates from the surface, rises into clouds, and returns as fresh rain, leaving salt and impurities behind. This cycle purifies trillions of gallons of water every day without any human intervention, powered only by the sun's gentle warmth and the Earth's rotation. The ocean processes and purifies more water in a single day than all human water treatment facilities combined could handle in a year. Ocean currents carry nutrients from deep waters to the surface, feeding microscopic plants that form the foundation of all marine life. These same currents distribute warmth from the tropics toward the poles and carry cool water back toward the equator, creating a global circulation system that keeps our planet's climate stable and comfortable. Without these currents, parts of the Earth would be unbearably hot while others would be frozen solid. The ocean's circulation system is so powerful that it transports more heat than all the world's. Rivers combined carry water. Even the ocean floor participates in this recycling. Sediments that have accumulated over millions of years are slowly drawn back into the Earth's interior through geological processes, only to emerge again as new seafloor elsewhere. The ocean bed is constantly being renewed, ensuring that even the deepest parts of the sea participate in the planet's endless cycle of renewal and rebirth. This geological recycling happens so slowly that it takes millions of years to complete a full cycle. Yet it has been operating continuously since the oceans first formed, maintaining the chemical balance that makes life possible. Underwater mountains and hidden landscapes beneath the ocean's surface lies a landscape more varied and dramatic than anything on dry land. Underwater mountain ranges stretch for thousands of miles, their peaks rising higher than the Himalayas. Vast plains spread across the seafloor, interrupted by canyons deeper than the Grand Canyon and valleys that dwarf any terrestrial landscape. This hidden topography shapes the flow of currents and creates habitats for countless species. The ocean floor contains the longest mountain range on Earth, stretching for more than 40,000 miles through all the worlds. Oceans. The Mid-Atlantic Ridge is an underwater mountain chain that runs down the center of the Atlantic Ocean like the spine of some enormous sleeping creature. This ridge is where new oceanic crust is born, as molten rock slowly emerges from deep within the Earth and cools into solid seafloor. The process happens so gradually that it would be imperceptible to human senses. adding mere inches to the ocean floor each year with the patience of geological time. This underwater mountain range is so vast that it would take more than a year to walk its entire length. If walking underwater were possible, see underwater mountains that don't quite reach the surface dot the ocean floor like islands in an inverted sky. These provide homes for deep-sea corals and fish, creating oases of life in the vast desert of the deep sea floor. Many of these underwater peaks have never been explored by humans, holding secrets and species that remain unknown to science. Scientists estimate there are more than 30,000 seamounts in the world's oceans, each one potentially harboring unique ecosystems that evolved in isolation. Some seamounts are so large, they create their own weather patterns in the ocean, influencing currents and creating upwelling patterns that bring nutrients to the surface. The ocean's role as Earth's thermostat. The oceans acts as our planet's thermostat, absorbing and releasing heat to keep global temperatures stable. Water has a remarkable ability to absorb large amounts of heat without changing temperature dramatically, which means the ocean can store vast quantities of thermal energy. During warm periods, the ocean absorbs excess heat. During cooler times, it releases this stored warmth back into the atmosphere. The ocean can absorb more than 1,000 times as much heat as the atmosphere without experiencing significant temperature changes. This thermal buffering happens on multiple timescales. Daily temperature swings are moderated by the ocean's thermal mass, which is why coastal areas rarely experience the extreme temperatures found far inland. Seasonal changes are similarly softened, creating more moderate climate near the sea. Even long-term climate variations are dampened by the ocean's ability to absorb and store heat for decades or centuries. The ocean has absorbed more than 90% of the excess heat trapped by greenhouse gases, preventing much more dramatic climate changes on land. The Gulf Stream carries warm water from the Caribbean toward Europe, raising temperatures across the North Atlantic by several degrees. Without this current, much of northern Europe would have a climate similar to northern Canada. Similar currents operate in every ocean, creating a global network of thermal regulation that keeps our planet comfortable for life. The Kuroshio Current in the Pacific performs a similar function for Japan, while the Brazil Current moderates temperatures along the South American coast. These ocean rivers of warm water transport more heat than the entire global energy consumption of human civilization. Microscopic gardens that feed the world floating near the ocean's surface are vast gardens of microscopic plants called phytoplankton. These tiny organisms are so small that millions could fit in a single drop of seawater. Yet collectively, they produce more oxygen than all the world's forests combined. They form the foundation of nearly every marine food chain, supporting everything from tiny fish to massive whales. A single cubic meter of ocean water can contain millions of these microscopic plants, all busily photosynthesizing and producing the oxygen that helps keep our planet's atmosphere breathable. These microscopic plants bloom in patterns that can be seen from space, creating swirls of green and blue that stretch across hundreds of miles of ocean. During peak blooming seasons, phytoplankton can turn entire sections of sea into underwater prairies, thick with life and bursting with the kind of productivity normally associated with the richest farmland. Some phytoplankton blooms are so large they cover areas larger than entire countries, visible from satellites as vast patches of color against the blue ocean background. The beauty of phytoplankton extends beyond their ecological importance. Under microscopes, individual species reveal intricate geometric patterns and crystalline structures that look like living snowflakes or tiny glass sculptures. Each species has its own unique shape, from spirals to stars to delicate chains that drift through the water like microscopic jewelry. To study phytoplankton is to discover an art gallery that has been creating masterpieces in miniature for billions of years. Some species create shells of pure glass, others build intricate calcium carbonate plates, and still others form long chains that spiral through the water in perfect mathematical curves. The rhythmic pulse of tidestides are the ocean's most visible breathing, a rhythm set by the gravitational dance between Earth, Moon, and Sun. Twice each day in most places, the sea rises and falls with a reliability that has served as a clock for coastal peoples throughout history. This gentle pulse creates some of the most peaceful natural sounds on Earth. The whisper of water advancing up a beach, the soft gurgle of tide pools filling and emptying. The gravitational forces that create tides are so predictable that they can be calculated precisely. For any location thousands of years into the future. The timing of tides follows patterns so precise they can be predicted centuries in advance. This predictability has a deeply calming quality, representing one of the few aspects of nature that follows rules we can understand completely. The moon's pull on the ocean creates a bulge of water that follows our satellite around the Earth, while the sun's gravity adds its own subtle influence to create the complex but predictable pattern of high and low tides. The combined gravitational effects create a celestial clockwork that has been ticking away for billions of years. In some places, tides create natural phenomena of extraordinary beauty. Tidal bores push walls of water up rivers, creating temporary waterfalls that flow upstream. In the Bay of Fundy, tides can rise and fall by more than 50 feet, twice daily, transforming the landscape from mudflats to deep harbors. These dramatic changes happen with such regularity that they create a kind of natural meditation on the passage of time. The tidal range in the Bay of Fundy is so extreme that more water flows in and out of the bay during each tidal cycle than flows through all the world's rivers combined. Ancient coral cities beneath the waves' coral reefs are among the oldest living structures on Earth, with some formations growing continuously for thousands of years. These underwater cities house more species per square foot than tropical rainforests, creating neighborhoods where fish, crustaceans, and countless other creatures live in complex communities. The corals themselves are animals, but they host algae in their tissues that photosynthesize like plants, creating partnerships that have thrived for millions of years. A single coral reef can support more than 4,000 species of fish, plus countless other forms of marine life. The Great Barrier Reef stretches for over 1,400 miles along the coast of Australia, making it the largest living structure on the planet. It can be seen from space, a testament to the power of small organisms working together over long periods of time. Each individual coral polyp is smaller than a fingernail, yet collectively they have built monuments that dwarf human construction projects. The Great Barrier Reef contains more than 2,900 individual reefs and 900 islands, creating a complex maze of underwater habitats that support an incredible diversity of life. Coral reefs grow with infinite patience, adding microscopic amounts of calcium carbonate each day to their skeletons. The process is so slow that it takes decades for a coral colony to grow large enough to notice. Yet over centuries and millennia, this patient construction creates underwater cathedrals of breathtaking beauty. The soft polyps wave gently in the current like underwater flowers, their movements creating a hypnotic dance that never stops. Some coral colonies are so old they began growing before the pyramids were built, slowly accumulating layer upon layer of calcium carbonate to create structures that will outlast most human civilizations. The sea's contribution to weather pattern. Raindrop that falls on land began its journey in the ocean. The sea is the engine that drives Earth's weather, constantly evaporating water that rises into the atmosphere to form clouds. This process connects every part of the planet through the water cycle, ensuring that moisture from the Pacific can eventually fall as snow in the Alps or rain in the Amazon rainforest. The ocean evaporates more than 400,000 cubic kilometers of water each year, enough to cover the entire United States with a layer of water 13 feet deep. Ocean temperatures strongly influence weather patterns around the world. Warm waters fuel hurricanes and typhoons, while cold currents can create fog and moderate temperatures along coastlines. The Pacific Ocean's temperature variations create phenomena like El Niño and La Niña, which can influence rainfall and temperature patterns across entire continents. These connections demonstrate how the ocean serves as the planet's circulatory system, distributing energy and moisture to maintain global climate balance. A single El Niño event can affect weather patterns from California to Australia, demonstrating the ocean's global influence. Storm systems that begin over the ocean often bring needed rainfall to land, but they start as gentle disturbances that grow slowly over thousands of miles of open water. Even the most powerful hurricanes begin as small areas of low pressure that gradually organize themselves into rotating systems. This gradual development reflects the ocean's tendency toward slow, patient processes that build power gradually rather than explosively. The energy in a single hurricane is equivalent to exploding a 10-megaton nuclear bomb every 20 minutes. Yet this enormous power develops gradually over days or weeks as the storm system slowly organizes itself over warm ocean waters. Marine migrations across endless blue sea of the longest journeys on Earth happen in the ocean. Gray whales travel up to 14,000 miles each year, following coastlines from feeding grounds in Alaska to breeding areas in Mexico. Arctic terns make even longer journeys, flying from Arctic to Antarctic and back again annually, spending most of their lives over open ocean. Sea turtles navigate across entire ocean basins using magnetic fields and ocean currents as their guides. These marine migrations represent some of the most remarkable navigation achievements in the natural world. These migrations often follow routes that have been used for thousands of generations, with knowledge passed from parents to offspring through methods we're only beginning to understand. Salmon return to the exact streams where they were born after years in the ocean, guided by scent memories that can distinguish their home waters from all others. Eels make the opposite journey, living in fresh water but returning to deep ocean areas to spawn. Some salmon can remember the chemical signature of their birth stream after traveling thousands of miles through the ocean for several years. The timing of these migrations often coincides with seasonal changes in ocean conditions, demonstrating how marine life has evolved to work with rather than against the sea's natural rhythms. Whales time their journeys to follow the blooming of plankton, while sea turtles coordinate their nesting with tides and moon phases. These ancient patterns create a sense of order and purpose in the vast ocean that is deeply comforting to contemplate. Many marine animals use a combination of magnetic fields, star positions, ocean currents, and even underwater sound to navigate with precision that surpasses the best human navigation systems. The ocean's sound library. The ocean is filled with sounds. though most are too low or too high for human ears to detect. Whales communicate across hundreds of miles using deep, resonant calls that travel through water much more efficiently than they would through air. These songs can last for hours, with complex melodies that some scientists compare to classical music. Blue whales produce the loudest calls in the animal kingdom. Sounds so powerful they can be detected by instruments thousands of miles away. A blue whale's call can travel halfway around the world under the right conditions. The sea itself creates music through the interaction of waves, currents, and underwater topography. Deep ocean currents generate infrasonic humming that serves as a constant bass note underlying all other ocean sounds. Waves breaking on shorelines create rhythmic percussion that varies with the size and spacing of the waves. Even the settling of sediments on the ocean floor contributes to this underwater symphony. The ocean contains natural sound channels where low-frequency sounds can travel for thousands of miles with minimal loss of intensity during calm weather. The ocean's sounds become more subtle and peaceful. The gentle lapping of small waves creates natural white noise that promotes relaxation and sleep. The distant sound of waves has been used as a sleep aid for centuries, with its consistent rhythm helping to slow heart rate and calm racing thoughts. This is perhaps why so many people find the sound of the ocean deeply soothing. It connects us to rhythms that are older than human civilization. The frequency patterns of ocean sounds closely match the brainwave patterns associated with deep, restful sleep, which may explain their universal appeal as relaxation aids. Underwater rivers and invisible waterfalls within. The ocean flow rivers of different temperature and salinity that remain distinct from surrounding waters for thousands of miles. The Gulf Stream is like an underwater river of warm water flowing through the cooler North Atlantic, maintaining its identity and temperature even as it travels from Florida to Norway. These currents have their own banks and flow patterns, just like rivers on land, but they're made of water flowing through water. The Gulf Stream carries more water than all the world's rivers combined, moving 30 billion gallons of water per second. Even more remarkable are underwater waterfalls, where dense, salty water cascades down underwater cliffs and valleys. The Denmark Strait Cataract between Greenland and Iceland is an underwater waterfall that carries more water than all the terrestrial waterfalls in the world combined. The falling water is so cold and dense that it sinks to the ocean floor and flows along the bottom for hundreds of miles. This underwater waterfall drops more than 11,000 feet, making it more than 3 times taller than Angel Falls, the highest terrestrial waterfall. These underwater rivers and waterfalls create a 3-dimensional landscape of flowing water that is constantly in motion yet remarkably stable. Ships passing overhead might never know they're crossing an underwater river that has been flowing along the same path for thousands of years. This hidden geography shapes the distribution of marine life and influences weather patterns, yet it remains largely invisible to surface observers. Some underwater rivers are so stable and persistent that marine life uses them as highways for migration, following the same current systems generation after generation. The sea's collection of fallen stars, the ocean floor is carpeted with meteorites that have fallen from space over millions of years. While most meteorites that strike land are eventually weathered away or buried, those that fall into the deep ocean are preserved in the sediments of the seafloor. These cosmic visitors accumulate slowly, adding their alien minerals to the vast libraries of the deep. Scientists estimate that the ocean floor contains millions of meteorites, representing a complete archive of the solar system's debris over geological time. Some meteorites have brought organic compounds from space, contributing to the ocean's rich chemical diversity. The largest underwater impact craters create unique habitats where rare minerals and unusual geological formations provide homes for specialized deep-sea communities. These impact sites serve as windows into both Earth's cosmic history and the resilience of life in extreme environments. The Chicxulub crater, which may have caused the extinction of the dinosaurs, was formed by an asteroid that struck in shallow ocean waters. The constant rain of cosmic dust also contributes to the ocean's composition, with thousands of tons of space material settling into the sea each year. This celestial seasoning has been flavoring the ocean for billions of years, connecting our local waters to the broader cosmos. Every swimmer is surrounded by atoms that once traveled between the stars, now dissolved in the gentle embrace of Earth's seas. Some of the water molecules in the ocean may have originated in interstellar space, carried to Earth by comets during the planet's early formation, seasonal transformations in polar waters in polar regions. The ocean undergoes dramatic seasonal transformations that create some of the most dynamic ecosystems on Earth. Sea ice forms and melts in patterns that have remained consistent for thousands of years, creating highways for polar bears and seals, while providing platforms for communities of ice-dwelling organisms. The formation and melting of sea ice is one of the most powerful seasonal rhythms on Earth, affecting weather patterns and marine life across entire hemispheres. Under the Arctic ice, a unique ecosystem thrives in near-constant darkness. Ice algae grow on the underside of sea ice, creating hanging gardens that feed tiny crustaceans, which in turn support fish, seals, and whales. The ice itself acts as a ceiling for this upside-down world, where bioluminescent creatures create light shows that reflect off the frozen surface above. The underside of Arctic sea ice supports some of the most productive ecosystems in the polar regions, with more life per square meter than many temperate ocean areas. The timing of ice formation and melting drives migration patterns across the Arctic. Whales follow the ice edge as it advances and retreats, feeding in the productive waters where ice meets open ocean. The seasonal rhythm of freezing and thawing creates a natural calendar that Arctic life has followed for millennia, demonstrating the ocean's role in organizing life on a continental scale. Some Arctic animals, like polar bears and Arctic seals, depend entirely on sea ice for their survival, using it as a platform for hunting, resting, and raising their young deep-sea vents, oases in the abyss and the ocean floor. Volcanic vents create underwater oases that support entire ecosystems without any energy from the sun. These hydrothermal vents spew superheated water rich in minerals, creating chemical gardens where bacteria convert sulfur compounds into food. Around these vents, communities of tube worms, crabs, and fish thrive in conditions that would be lethal to most surface life. These vent communities represent one of the few ecosystems on Earth that operates entirely independently of solar energy. The water around hydrothermal vents can reach temperatures of over 750 degrees Fahrenheit. Yet just a few feet away, the surrounding deep ocean remains near freezing. This creates dramatic temperature gradients that different species have learned to navigate. Some organisms live right at the boundary between scalding and freezing water, thriving in conditions that seem impossible to surface dwellers. The tube worms found at hydrothermal vents can grow to be 8 feet long and have no mouth or stomach, depending entirely on symbiotic bacteria in their tissues for nutrition. These vent communities represent some of the most isolated ecosystems on Earth, yet they demonstrate life's incredible adaptability. Many vent species are found nowhere else, having evolved in isolation to take advantage of the unique chemistry of their deep-sea environments. The discovery of these communities revolutionized our understanding of where life can exist, showing that the ocean's depths hold possibilities we're still learning to imagine. Some scientists believe that life on Earth may have first evolved around hydrothermal vents, making these deep-sea oases potential cradles of all life on our planet. The ocean's memory of ice, ages locked in the ocean's deep waters and sediments, is a complete record of Earth's climate history, including detailed information about past ice ages. Deep ocean cores contained layers of sediment that built up year by year over millions of years, creating a timeline that scientists can read like tree rings. These cores reveal how ocean temperatures, chemistry, and circulation patterns have changed through multiple ice ages. Each layer of sediment contains microfossils and chemical traces that tell the story of ancient climates with remarkable precision. During ice ages, so much water was locked up in glaciers that sea levels dropped by hundreds of feet, exposing vast areas of what is now the ocean floor. Land bridges appeared between continents, allowing migration of species that are now separated by deep water. The ocean remembers these changes in its chemical composition and the distribution of marine life. Coral reefs that now lie far underwater once grew in shallow tropical seas, while areas that are now deep ocean were once coastal plains where early humans may have walked. The transition periods between ice ages and warmer eras created some of the most dramatic changes in ocean history. As glaciers melted, massive amounts of fresh water poured into the sea, temporarily disrupting ocean circulation patterns and creating climate changes that affected the entire planet. These ancient climate shifts demonstrate the ocean's central role in Earth's long-term climate stability. The ocean's sediment record shows that climate changes that took thousands of years in the past are now happening in decades due to human activities. Phosphorescent seas and living light shows in certain nights in certain places. Entire sections of the ocean light up with bioluminescence. When disturbed by waves or swimming creatures, millions of microscopic organisms flash simultaneously, creating seas that glow like liquid starlight. This phenomenon, known as a phosphorescent bay or bioluminescent bay, transforms nighttime swimming into an otherworldly experience. The light produced is so bright it can be seen from aircraft flying overhead, creating patches of glowing water that look like underwater cities. The light is typically blue-green, the color that travels farthest through seawater. When a hand moves through phosphorescent water, it leaves a trail of light that fades slowly, like writing with liquid electricity. Fish swimming through these waters appear as shooting stars, their movements outlined in gentle fire. Even waves breaking on shore become visible streams of light flowing up the beach. The bioluminescence is triggered by physical disturbance, so every movement in the water creates cascades of light that ripple outward like underwater lightning. These light shows are created by single-celled organisms called dynamos, which flash when agitated as a defense mechanism. The simultaneous flashing of millions of these tiny creatures creates displays that can be seen from boats or aircraft. The phenomenon is so beautiful that it has inspired countless legends about magical seas and underwater spirits. Some bioluminescent bays are so bright that you can read a book by their light on a dark night, while others produce subtle glows that are visible only when the water is disturbed by swimming or boat movement. The ancient dance of ocean currents have been flowing in similar patterns for millions of years, creating underwater highways that marine life has learned to navigate with precision. These currents are driven by differences in water temperature, salinity, and the Earth's rotation, creating a global circulation system that connects every ocean on the planet. The patterns of ocean circulation are so stable that some current systems have been flowing along the same routes for tens of millions of years. The thermaline circulation, sometimes called the global conveyor belt, is a slow-moving current system that takes about 1,000 years to complete one full cycle around the world. Surface water sinks in the North Atlantic and Antarctic, flowing along the ocean floor toward the equator and then rising again in the Pacific and Indian Oceans. This circulation carries nutrients, heat, and dissolved gases throughout the global ocean. A single water molecule might spend centuries traveling this global conveyor belt before returning to its starting point, marine. Animals have evolved to use these currents for transportation, timing their reproduction and migration to take advantage of predictable water movements. Sea turtle hatchlings enter specific currents that will carry them to feeding areas, while adult fish follow current systems that bring them back to spawning grounds. This ancient partnership between life and water demonstrates the ocean's role as both habitat and highway. Some marine species have life cycles that are perfectly synchronized with current patterns, ensuring that their young are carried to the right places at the right times for survival and growth. Coral gardens in deep darkness, while tropical coral reefs capture most attention. Equally beautiful coral gardens grow in the cold, dark waters of the deep ocean. These deep-sea corals don't depend on photosynthesis, but instead capture food particles from the water around them. They grow incredibly slowly, with some deep-water coral colonies estimated to be thousands of years old. Some deep-sea corals are so old they began growing during the Roman Empire and are still alive today. Cold water corals create three-dimensional structures that provide homes for fish, crustaceans, and other deep-sea creatures. These deep coral gardens often grow on underwater mountains and ridges, creating oases of life in the vast desert of the deep seafloor. The corals themselves come in colors rarely seen in shallow water: brilliant oranges, deep purples, and pure whites that glow softly in the darkness. Deep-sea coral reefs can be just as complex and diverse as their shallow water counterparts, supporting hundreds of species in a single location. The discovery of these deep-sea coral ecosystems has revealed that coral reefs exist throughout the ocean, not just in tropical shallows. Many of these deep coral gardens have never been seen by human eyes, representing vast underwater landscapes that remain largely unexplored. Their existence demonstrates that the ocean's capacity for beauty extends from surface to seafloor. Some deep-sea coral reefs cover areas larger than entire countries, creating underwater mountain ranges decorated with living coral formations that rival any terrestrial landscape in their beauty and complexity. The sea's healing properties throughout human history. People have recognized the ocean's healing properties. Seawater contains minerals and elements that can benefit human health, from the magnesium that helps relax muscles to the negative ions generated by crashing waves that may improve mood and energy levels. The sound of waves has measurable effects on stress hormones and brainwave patterns. Modern research has confirmed many traditional beliefs about the ocean's therapeutic effects, showing that time spent near the sea can reduce anxiety, lower blood pressure, and improve overall well-being. Saltwater has natural antiseptic properties and has been used to treat wounds and skin conditions for thousands of years. The minerals dissolved in seawater, including potassium, calcium, and magnesium, are essential nutrients that the human body requires for proper functioning. Ocean swimming provides these minerals through skin absorption, while also providing gentle exercise that supports circulation and joint health. The buoyancy of salt water reduces stress on joints, making ocean swimming an ideal form of therapy for people with arthritis and other mobility issues. The rhythmic sound of waves has been scientifically shown to activate the parasympathetic nervous system, promoting relaxation and better sleep. The frequency of wave sounds matches patterns that the brain associates with safety and rest, which may explain why ocean sounds are among the most popular choices for relaxation and sleep aids. This connection suggests that our attraction to the sea may be rooted in deep biological responses that recognize the ocean as a source of healing and renewal. Studies have shown that people who live near the ocean tend to report higher levels of life satisfaction and lower rates of anxiety and depression compared to those living inland. Underwater forests that sway like dreams. Kelp forests create underwater cathedrals where giant algae sway gently in ocean currents. These underwater forests can grow over 100 feet tall, creating canopies that filter sunlight into dappled patterns reminiscent of terrestrial woods. The kelp fronds move with a dreamlike quality, bending and flowing in response to water movements that are too subtle for human senses to detect directly. Giant kelp is one of the fastest growing organisms on Earth, capable of growing up to 2 feet in a single day under perfect conditions. Fish navigate through kelp forests like birds flying through trees, using the vertical structure for protection and feeding. Sea otters wrap themselves in kelp fronds while sleeping at the surface, using the algae as natural anchors to prevent drifting away from their preferred resting areas. The entire ecosystem moves with a synchronized rhythm that creates one of the most peaceful underwater environments. Kelp forests support more than 1,000 species of marine life, creating underwater jungles that rival tropical rainforests in their biodiversity. Giant kelp can grow up to 2 feet per day under ideal conditions, making it one of the fastest growing organisms on Earth. Despite this rapid growth, kelp forests have a gentle, timeless quality that makes them popular destinations for underwater meditation and relaxation. The constant, gentle movement of the kelp creates natural white noise that many divers find deeply calming. The play of light filtering through the kelp canopy creates an ever-changing pattern of shadows and golden beams that dance across the seafloor like underwater. Aurora. The ocean's role in creating clouds. Cloud in the sky began as water evaporated from the ocean's surface. The process is so gentle and constant that it's nearly invisible, yet it moves more water than all the world's rivers combined. Ocean evaporation provides the moisture for virtually all precipitation on land, connecting desert rainfall to tropical seas through the atmosphere. The ocean evaporates approximately 86% of all water that enters the atmosphere, making it the primary source of the water cycle that sustains all terrestrial life. The rate of evaporation varies with temperature, wind, and humidity, creating patterns that can be observed from space. Satellite images often show streams of water vapor flowing from the ocean toward land, invisible rivers in the sky that carry moisture from sea to continent. These atmospheric rivers can transport as much water as the Amazon River, delivering it as rain or snow thousands of miles inland. Some atmospheric rivers carry enough water to supply the entire water needs of California for several months. The process of evaporation also helps cool the ocean surface, creating a natural air conditioning system that moderates global temperatures. This cooling effect is strongest in tropical regions, where intense solar heating drives rapid evaporation that carries excess heat energy into the atmosphere. The result is a global climate regulation system powered entirely by the sun and the sea working together. Without this oceanic evaporation, Earth's countenance would be barren deserts, as the ocean is the ultimate source of virtually all fresh water on land. Sleeping giants, whales at rest. Whales, the ocean's gentle giants, have developed unique ways to sleep while maintaining the ability to breathe at the surface. Some species enter a state called logging, where they float motionless at the surface like living logs. Others engage in spy-hopping sleep, where they periodically surface to breathe while remaining largely unconscious. Unlike humans, whales never fall into completely unconscious sleep, as they must consciously control their breathing even while resting. Sperm whales have been observed sleeping vertically in the water column, with their massive heads pointing toward the surface and their tails hanging down into the depths. These sleeping pods of whales hang suspended in the water like enormous sleeping flowers, rising and falling gently with their breathing. The sight of sleeping whales represents one of the most peaceful scenes in nature. Scientists have discovered that whales sleep for only about 7% of their day, much less than most mammals. Yet they seem to function perfectly well on this minimal rest. Scientists believe whales may dream, as they show brainwave patterns during sleep that are similar to those associated with dreaming in other mammals. The content of a whale's dreams remains a mystery, but given their complex social behaviors and long-distance migrations, their dreams might include memories of distant seas and the songs of other whales heard across vast ocean distances. Some researchers speculate that whale dreams might include mental maps of ocean basins, memories of feeding grounds, or replays of complex social interactions with their pod members. The sea's natural pharmacy. The ocean is a vast pharmacy containing compounds that have revolutionized human medicine. Many life-saving drugs were originally discovered in marine organisms, from antibiotics found in deep-sea bacteria to anti-cancer compounds isolated from sea sponges. The unique chemistry of marine life, evolved in the challenging conditions of salt water, has produced molecules found nowhere else in nature. Scientists estimate that less than 1% of marine organisms have been tested for potential medical applications, suggesting vast untapped potential for new medicines. Sea sponges, despite appearing plant-like, are actually complex animals that produce some of the most potent natural chemicals known to science. These compounds help sponges defend themselves from the many creatures that would otherwise eat them. Human researchers have learned to synthesize many of these defensive compounds for use in treating diseases that affect millions of people worldwide. Several important anti-cancer drugs, including some used to treat leukemia and solid tumors, were originally derived from marine sponges. Even simple seaweed contains compounds that benefit human health. Various species of marine algae produce natural antioxidants, anti-inflammatory agents, and nutrients that support immune system function. Traditional coastal cultures have used seaweed as both food and medicine for thousands of years. Knowledge that modern science is now validating and expanding upon. Some seaweeds contain compounds that can help regulate blood pressure, reduce cholesterol, and support healthy brain function. Tidal pools. Windows to ocean. Life tidal pools are perhaps the ocean's most accessible classrooms, where visitors can observe marine life up close during low tide. These natural aquariums are created when retreating tides leave behind pools of seawater in rocky depressions. Each pool becomes a miniature ecosystem where sea anemones, crabs, fish, and algae live together in a space small enough to explore in detail. Tidal pools create some of the most harsh and variable environments on Earth. With conditions changing dramatically twice each day, the creatures living in tidal pools must be remarkably adaptable, surviving both underwater conditions during high tide and exposure to air, temperature changes, and varying salinity during low tide. This daily cycle of submersion and exposure has created some of the most resilient organisms in the ocean, species that can thrive in conditions that would challenge life anywhere else. Some tidal pool organisms can survive being completely dried out for hours, then resume normal activity when the tide returns. Visiting tidal pools provides an intimate connection with ocean life that is difficult to achieve in deeper waters. The small scale of these environments allows for patient observation of marine behavior, from the feeding patterns of sea anemones to the social interactions of hermit crabs. Many people find tidal pool exploration meditative, providing a chance to slow down and observe the intricate details of ocean life. Each tidal pool is like a microcosm of the ocean, containing representatives of many major groups of marine life in a space small enough to study carefully. The ocean's underground rivers beneath the sea floor flow vast rivers of water that may contain more fresh water than all surface rivers combined. These submarine groundwater systems carry water from inland areas out to sea through underground channels that can extend for hundreds of miles beneath the ocean floor. The water emerges through underwater springs that create oases for marine life. These hidden freshwater systems were only recently discovered and may represent one of Earth's largest freshwater reserves. These submarine springs often support unique ecosystems where fresh and salt water mix, creating environments with intermediate salinity that host species found nowhere else. The mixing zones between fresh groundwater and seawater create complex chemistry that can support specialized communities of bacteria and other microorganisms. Some of these underwater springs are large enough to be detected by satellites, appearing as patches of different colored water on the ocean surface. The discovery of these underwater river systems has revealed that the connection between land and sea extends far below the visible surface. Rainfall in mountains hundreds of miles inland may eventually emerge as freshwater springs on the deep ocean floor, creating connections between terrestrial and marine environments that scientists are still learning to understand. These submarine groundwater systems play important roles in coastal ecosystems and may become increasingly important as sources of fresh water for human use. Bioluminescent bays, nature's nightlights in a few rare locations around the world. Bays and lagoons glow with natural light produced by millions of microscopic organisms. These bioluminescent bays create ethereal environments where every movement in the water produces trails of blue-green light. Swimming in a bioluminescent bay is like moving through liquid starlight, with each stroke creating galaxies of glowing particles. Only a handful of these magical bays exist worldwide, making them among Earth's rarest natural phenomena. The organisms responsible for this phenomenon are deep, single-celled creatures that flash when disturbed. Scientists believe this flashing serves as a burglar alarm, startling potential predators or attracting larger predators that might eat whatever is threatening the deep. The result is one of nature's most beautiful defense mechanisms. The dinoflagellates require very specific conditions to thrive, including the right temperature, salinity, and nutrient levels, which makes bioluminescent bays extremely fragile ecosystems. The intensity of bioluminescence varies with water temperature, pollution levels, and the health of the dinoflagellate population. The most spectacular displays occur on warm, dark nights, when conditions are perfect for both the organisms and human observers. These magical environments provide experiences that many visitors describe as life-changing, connecting them to the wonder and mystery of ocean life. Some bioluminescent bays have been damaged by pollution and development, making conservation of these unique ecosystems critically important. The sea's role in Earth's rotation. The ocean's tides actually slow Earth's rotation very slightly, adding about 2.3 milliseconds to each day every century. This happens because tidal friction creates a drag effect as water moves across the seafloor and coastlines. Over geological timescales, this tidal braking has significantly affected the length of Earth's day and the distance between Earth and Moon. When Earth first formed, days were only about 6 hours long, and the Moon was much closer to our planet. In Earth's early history, days were much shorter, perhaps only 6 to 8 hours long, and the Moon was much closer. The gravitational interaction between Earth's oceans and the Moon has gradually slowed our planet's rotation, while pushing the Moon farther away. This process continues today, though so slowly that it's imperceptible to human experience. The Moon moves away from Earth by about 1.5 inches per year, a rate that can be measured precisely using laser reflectors left on the lunar surface by Apollo astronauts. The oceans roll in. Planetary mechanics demonstrates the interconnectedness of all Earth systems. Even the gentle rise and fall of tides participates in cosmic scale processes that have shaped our planet's development over billions of years. This connection between daily tidal rhythms and the deep time of astronomical evolution adds another layer of wonder to the simple experience of watching waves. The tidal forces that slow Earth's rotation also help stabilize our planet's climate by preventing extreme wobbling of the rotation axis. Deep ocean circulation, the planet's slow heartbeat. Deep ocean circulates in patterns so slow they seem almost motionless. Yet this circulation system is essential for planetary climate stability. Deep water formed at the poles sinks to the ocean floor and flows toward the equator in currents that take centuries or millennia to complete their journeys. This deep circulation carries oxygen from the surface to the deepest parts of the ocean while transporting nutrients back upward. Without this circulation, the deep ocean would become depleted of oxygen and unable to support life. The Antarctic Circumpolar Current is the longest current system in the world, flowing around Antarctica and connecting the Atlantic, Pacific, and Indian Oceans. This current is like a massive conveyor belt that moves 600 times more water than the Amazon River, stirring the world's oceans and helping to distribute heat and nutrients globally. The Antarctic Circumpolar Current is the only current that flows completely around the globe, making it unique among ocean circulation systems. This deep circulation system operates like a planetary heartbeat, pumping life-giving water through the depths with the steady persistence of geological time. The movement is so slow that a single water molecule might spend centuries in the deep ocean before returning to the surface. Yet this patient circulation is what keeps the ocean healthy and habitable for life at all levels. Scientists sometimes refer to this system as the ocean's breathing, as it slowly inhales and exhales water between the surface and the depths over cycles that last thousands of years. The sea's ancient salt deposits. Salt in today's oceans tells the story of billions of years of erosion and mineral transport. Every grain of salt dissolved in seawater represents countless years of rain falling on mountains, wearing away rocks grain by grain, and carrying those minerals through rivers into the sea. The ocean has been collecting these mineral treasures for so long that it has become a liquid. Museum of Earth's Geological History. The ocean contains enough salt to bury all the continents under a layer 500 feet thick. Different regions of the ocean have slightly different salt compositions, depending on which rivers feed them and what types of rocks dominate their watersheds. The Dead Sea, though technically a lake, contains salts that make it nearly 10 times saltier than the ocean, creating water so dense that swimmers float effortlessly on the surface like corks. The unique mineral composition of different bodies of salt water has been used throughout history for various therapeutic and industrial purposes. The process of salt accumulation continues today at the same gentle pace it has maintained for eons. Every river carries its tiny tribute of dissolved minerals to the sea, adding to the vast chemical library that makes ocean water fundamentally different from any terrestrial water source. This ancient accumulation creates the unique environment that supports all marine life. Despite the constant input of salt from rivers, ocean salinity remains remarkably constant because various geological processes remove salt at the same rate. It's added whale songs that travel across oceans. Songs of whales are among the most haunting and beautiful sounds in the natural world. Humpback whales create complex songs that can last for up to 30 minutes, with themes and variations that suggest a sophisticated musical intelligence. These songs change gradually over time, with new phrases appearing and old ones disappearing, almost as if whale culture itself is evolving through music. All the males in a population sing the same song, but the song slowly changes over months and years, with innovations spreading through the population like musical fashions. Blue whales produce calls so low and powerful that they can travel across entire ocean basins. A blue whale singing off the coast of California might be heard by another blue whale near Japan. The sound traveling through the deep ocean channels, where low-frequency waves can propagate for thousands of miles without significant loss of intensity. These calls are below the range of human hearing, but when played back at higher speeds, they reveal complex patterns and emotional depth. Scientists studying whale songs have discovered that different populations have different dialects, much like human languages. Pacific humpback whales sing different songs than Atlantic humpback whales, and these songs gradually change as they spread through populations. The ocean becomes a vast concert hall where whales share their music across distances that dwarf any human communication system. Some whale calls are so loud they can be heard by other whales on the opposite side of an ocean basin, making them among the longest distance biological communications on Earth. The ocean's role in oxygen production. While rainforests are often called the lungs of the Earth, the ocean actually produces more oxygen than all terrestrial plants combined. This oxygen comes primarily from microscopic marine plants called phytoplankton, which carry out photosynthesis in the sunlit surface waters. A single drop of seawater can contain thousands of these tiny oxygen factories, each one busily converting carbon dioxide and sunlight into the oxygen we breathe. The ocean produces approximately 70% of the oxygen in Earth's atmosphere. The oxygen production varies with seasons and ocean conditions, creating rhythms that affect the entire planet's atmosphere. During spring blooms, when conditions are perfect for phytoplankton growth, oxygen production can increase dramatically, sometimes creating visible changes in ocean color that can be seen from space satellites. These blooms can cover areas larger than entire countries, turning vast sections of ocean green. With the abundance of microscopic plant life, this oxygen doesn't just benefit marine life, it mixes with the atmosphere and helps maintain the oxygen levels that all land-dwelling creatures depend on. Every other breath you take contains oxygen that was recently produced by microscopic marine plants floating in seas that might be thousands of miles away. The ocean literally helps keep the planet breathing. Without the ocean's oxygen production, Earth's atmosphere would have far too little oxygen to support complex life forms like mammals and birds. Deep-sea creatures that never see sunlight in the eternal darkness of the deep ocean, live creatures so strange they seem like aliens from another world. Giant isopods, looking like enormous pillbugs, scavenge the seafloor for food that drifts down from above. Vampire squids, despite their fearsome name, are gentle filter feeders that drift through the water column like living umbrellas. Catching marine snow, the constant rain of organic particles that falls from the surface. These deep-sea giants can grow to enormous sizes in the stable, cold environment of the depths. Many deep-sea fish have transparent heads, allowing their tubular eyes to look upward through their own skulls to spot the faint silhouettes of prey against the slightly lighter surface waters far above. These Borellii fish represent evolution's creative solution to hunting in a world without light, where every photon must be captured and used efficiently. Their transparent heads are filled with fluid that protects their sensitive eyes, while allowing them to rotate upward to track potential prey. The deep-sea anglerfish carries its own lure, a bioluminescent bulb that dangles in front of its enormous mouth like a fishing rod tipped with living light. In the vast darkness of the deep ocean, this tiny light becomes an irresistible beacon for smaller fish, drawn to what might be the only light they will ever see in their entire lives. Female anglerfish can be hundreds of times larger than males, with tiny males fusing permanently to the female's body to form bizarre two-in-one creatures. Underwater, avalanches of sediment beneath the calm surface of the ocean. Massive underwater landslides, called turbidity currents, race down continental slopes at speeds that can exceed 60 miles per hour. These underwater avalanches carry enormous volumes of sediment from shallow waters into the deep ocean basins, carving submarine canyons that rival the Grand Canyon in size and dramatic beauty. A single turbidity current can move more sediment than all the world's rivers combined carry in an entire year. When these sediment flows finally come to rest on the deep ocean floor, they create some of the flattest surfaces on Earth. Abyssal plains that stretch for thousands of miles with less variation in elevation than a parking lot. These plains are covered with sediments that have been sorted by the flowing water into layers as fine and precise as the pages of a book, each layer recording a moment in the ocean's history. The abyssal plains cover more area than all the world's continents. Combined, the turbidity currents that create these formations happen rarely, perhaps once every few thousand years in any given location. But when they do occur, they reshape vast areas of the seafloor in a matter of hours, demonstrating the ocean's ability to create dramatic change through sudden, powerful events balanced against millennia of patient, gradual processes. These underwater avalanches have been known to break submarine cables, cutting off international communications when they strike. Marine snow, the ocean's gentle blizzard in the depths of the ocean falls a constant, gentle snowfall called marine snow. These snowflakes are not made of ice, but of organic particles, dead plankton, fish scales, fecal pellets, and other biological debris that drifts slowly downward from the productive surface waters. This marine snow provides food for deep-sea creatures and plays a crucial role in the ocean's carbon cycle. The marine snow creates a constant supply of nutrients that supports life in the deepest parts of the ocean. The descent of marine snow is incredibly slow, with particles taking weeks or months to drift from the surface to the deep ocean floor. During this long journey, the particles are eaten and re-excreted by countless organisms, constantly changing in composition and size. What reaches the seafloor is a concentrated collection of nutrients that feeds bottom-dwelling communities. Some particles are so light they may take months to sink just a few hundred feet. Scientists who study the deep ocean often describe marine snow as one of the most peaceful phenomena they observe. Through deep-sea cameras, it appears as a constant, gentle drift of particles against the black background of the deep ocean, creating a sense of serenity that rivals any terrestrial snowfall. The marine snow creates feeding opportunities at every depth, supporting communities of filter feeders and scavengers throughout the water column. The ocean's magnetic memory. Ocean floor contains a detailed record of Earth's magnetic field changes over millions of years. As new oceanic crust forms at mid-ocean ridges, iron-rich minerals align themselves with the planet's magnetic field before cooling into solid rock. This creates bands of magnetized rock that preserve the direction and intensity of Earth's magnetic field at the time they were formed. The ocean floor is like a vast tape recorder, continuously recording Earth's magnetic history. By studying these magnetic stripes, scientists have learned that Earth's magnetic field reverses periodically, with magnetic north becoming magnetic south and vice versa. These reversals happen at irregular intervals, sometimes every few 100,000 years, sometimes not for millions of years. The ocean floor has recorded every reversal for the past 180 million years. During magnetic reversals, Earth's magnetic field becomes very weak, potentially exposing the planet to harmful cosmic radiation. This magnetic memory stored in the seafloor has been crucial for understanding plate tectonics and the movement of continents over geological time. The ocean doesn't just flow above the Earth's surface, it actually preserves the planet's magnetic history in its very foundation, making the seafloor a vast library of geophysical information. The study of magnetic stripes on the ocean floor provided some of the key evidence that confirmed the theory of plate tectonics in the 1960s. Underwater mountains of life rising from the deep ocean floor are thousands of seamounts. Underwater mountains that create islands of life in the vast desert of the deep sea. These volcanic peaks, many of which rise thousands of feet from the seafloor without breaking the surface, provide hard surfaces for deep-sea corals and sponges to attach to in an environment that is otherwise mostly soft sediment. Scientists estimate that there are more than 100,000 seamounts in the world's oceans. Each seamount becomes its own ecosystem, often hosting species that are found nowhere else on Earth. The currents flowing around these underwater mountains bring nutrients up from the depths and create upwelling patterns that support rich communities of fish, crabs, and other marine life. Many seamounts have never been explored, representing unknown worlds that may harbor species science has yet to discover. Some seamounts support more biodiversity than tropical coral reefs. The isolation of seamounts has made them natural laboratories for evolution. Species living on one seamount may be completely cut off from those on neighboring peaks, leading to the development of unique characteristics over thousands of generations. Some seamounts have been separated from their nearest neighbors for millions of years, enough time for entirely new species to evolve. The endemic species found on seamounts often exist nowhere else on Earth, making these underwater mountains irreplaceable reserves of biological diversity. The ocean's role in global communication before satellites and fiber optic cables. The ocean served as humanity's primary highway for long-distance communication. Messages in bottles, while often thought of as romantic gestures, were actually used for scientific research and emergency communication. Ocean currents would carry these messages across vast distances, sometimes delivering them to shores thousands of miles from where they were released. Some messages in bottles have traveled for decades before being found, creating unexpected connections between distant shores and different generations. Today, the majority of international internet traffic travels through cables laid on the ocean floor. These submarine cables, often no thicker than a garden hose, carry more than 95% of international data and voice transfers. The ocean floor has become a vast network of communication lines connecting every continent, making global instant communication possible. If all submarine cables were laid end to end, they would wrap around the Earth more than 32 times. The ocean continues to facilitate communication in other ways as well. Whales and dolphins use the ocean's acoustic properties to communicate across vast distances, while human researchers use underwater sound channels to track ocean temperature and monitor marine life. The sea has always been a medium for connection, linking distant shores and distant minds. Military submarines use natural underwater sound channels to communicate across entire ocean basins without detection. Tide pool universes. Tide pool is a miniature universe, complete with its own weather patterns, seasonal changes, and complex ecosystems compressed into a space small enough to step across. These temporary habitats are created twice daily as tides retreat, leaving behind pools of seawater in rocky depressions along coastlines around the world. Each tide pool contains a complete ecosystem with predators, prey, herbivores, and decomposers all living together in a space that might be only a few feet across. The creatures living in tide pools are among the most adaptable on Earth, capable of surviving both underwater marine conditions and temporary exposure to air, sun, and rain. Sea anemones close their tentacles and wait out low tide like flowers closing for the night, while hermit crabs scurry between pools, searching for better shells or richer feeding grounds. Some tide pool animals can survive temperature changes of more than 40 degrees Fahrenheit in a single day. The daily rhythm of tide pool life creates natural meditation opportunities for human observers. Watching sea anemones slowly open as fresh seawater returns, or observing the intricate social interactions between different species in these small spaces, provides an intimate glimpse into the complexity and beauty of marine ecosystems that is available to anyone willing to sit quietly and watch. Many tide pool species time their activities to the tidal cycle, spawning, feeding, and moving with clockwork precision. The sea's ancient forests millions of years ago. Vast forests grew in areas that are now covered by ocean, as sea levels rose and fell over geological time. These ancient woodlands were sometimes preserved beneath marine sediments, creating underwater fossil forests that tell the story of Earth's changing climate and geography. These submerged forests provide unique windows into past climates and ecosystems that existed when the world was very different from today. Off the coast of Alabama, divers can explore a 60,000-year-old cypress forest that was preserved when sea levels were much lower during the last ice age. The trees stand like ghostly sentinels on the seafloor. They were preserved by the anaerobic conditions of marine burial. Fish swim between trunks that once swayed in terrestrial breezes, creating surreal underwater landscapes that blur the boundary between land and sea. The preserved wood is so well preserved that tree rings can still be counted and analyzed. These submerged forests provide unique habitats for marine life while serving as time capsules that preserve information about past climates and ecosystems. They remind us that the boundary between ocean and land is fluid over geological time, constantly shifting as ice ages come and go and sea levels rise and fall. Some submerged forests are so well preserved that they still contain the remains of land animals that lived among the trees before. They were flooded by rising seas, underwater lakes. Within the ocean, in some parts of the deep ocean, pools of extremely dense, salty water collect in seafloor depressions, creating underwater lakes with distinct boundaries between the dense brine and the surrounding seawater. These brine pools have their own shorelines where different water masses meet, sometimes complete with waves at the interface between different density layers. The boundaries between these underwater lakes and the surrounding seawater are so distinct that submarines can actually float on top of them. The water in these underwater lakes is often so dense and oxygen poor that it can be toxic to most marine life. Yet specialized bacteria and other microorganisms thrive in these extreme conditions. Some fish can swim above these brine pools as if they were flying over a terrestrial lake, occasionally dipping down to feed at the interface where nutrients concentrate. The brine pools often contain high concentrations of methane and hydrogen sulfide, creating chemistry that supports unique ecosystems. These formations create some of the most alien-looking environments on Earth, with clear boundaries between different water masses that look almost solid to underwater observers. They demonstrate the ocean's ability to create distinct habitats and microclimates, even in the seeming uniformity of the deep sea. Some brine pools have been stable for thousands of years, creating permanent underwater lakes that exist within the ocean itself. The ocean's time capsules. Deep ocean sediments contain time capsules that preserve detailed records of Earth's history going back millions of years. Each layer of sediment represents a slice of time containing microscopic fossils, chemical traces of ancient climates, and even cosmic dust from distant supernovas. By drilling cores from these sediment layers, scientists can read the ocean's memory of ice ages, volcanic eruptions, asteroid impacts, and gradual climate changes. These sediment cores provide the most complete record of Earth's climate history, available anywhere on the planet. Some sediment layers contain ash from volcanic eruptions that happened thousands of years ago, providing precise time markers that help correlate events around the globe. Other layers preserve pollen grains that were carried by wind from distant continents, showing how terrestrial ecosystems changed over time. The deep ocean has quietly been collecting and preserving these historical records, while life above continued its daily rhythms. Individual volcanic ash layers can sometimes be traced across entire ocean basins, providing snapshots of specific moments in Earth's history. The most recent layers of sediment contain traces of human activity, microscopic plastic particles, artificial chemicals, and isotopes from nuclear testing. The ocean is currently recording our era just as faithfully as it recorded the age of dinosaurs, creating a permanent archive of the Anthropocene that will be readable millions of years in the future. Future geologists will be able to identify the exact moment when human influence on Earth's systems became globally significant by studying ocean sediments. Bioluminescent waves. Some of the ocean's most magical moments occur when waves themselves become sources of light. When certain types of bioluminescent plankton are agitated by wave action, entire breakers can light up with blue-green fire as they crash onto beaches. This phenomenon turns nighttime surf into a display of living electricity, with each wave crest glowing like liquid lightning. The light is so bright that it can illuminate surfers and swimmers, creating otherworldly scenes that seem more like science fiction than natural phenomena. The light is produced by single-celled organisms called dinoflagellants, which flash when disturbed as a defense mechanism. When millions of these organisms are concentrated near shore, even gentle wave action can trigger spectacular displays. Surfers riding through bioluminescent waves report feeling like they're surfing through liquid starlight, with their boards leaving glowing trails in the water. The phenomenon can be so intense that footprints glow in the sand where bioluminescent water washes onto the beach. These displays are relatively rare and unpredictable, making encounters with bioluminescent waves particularly memorable for those fortunate enough to witness them. The phenomenon reminds us that the ocean continues to hold surprises and magical moments for those who spend time near its shores, especially during the quiet hours of darkness when its hidden lights can shine. Some beaches are famous for bioluminescent displays, but the phenomenon can occur almost anywhere where conditions are ripe for. Dinoflagellate blooms, the ocean's role in planetary weather. Ocean drives Earth's weather systems through processes that operate on scales from local sea breezes to global circulation patterns. The daily cycle of land heating up faster than water creates onshore breezes during the day and offshore breezes at night, providing natural air conditioning for coastal areas. These local effects scale up to influence weather patterns across entire continents. The ocean's thermal stability creates buffer zones that moderate temperature extremes and provide moisture for weather systems. Ocean temperatures largely control the formation and intensity of storms. Hurricanes and typhoons draw their energy from warm surface waters, growing stronger as they pass over warmer areas and weakening as they encounter cooler waters or move over land. The ocean acts as both fuel and brake for these powerful weather systems, providing energy when conditions are right and absorbing excess energy when storms begin to dissipate. A single hurricane can extract more energy from warm ocean water than the entire global power grid generates in a year. In Nino and La Niña events demonstrate how small changes in ocean temperature can affect weather patterns worldwide. These periodic warming and cooling cycles in the Pacific Ocean influence rainfall patterns from California to Australia, showing how the ocean connects weather systems across the entire planet through atmospheric circulation patterns. During El Niño events, changes in Pacific Ocean temperatures can cause droughts in some regions and floods in others, demonstrating the ocean's global influence on weather and climate. Deep ocean mysteries. Despite decades of exploration, the deep ocean remains largely mysterious. Scientists estimate that less than 5% of the ocean has been explored in detail, meaning that vast areas of our planet remain as unknown as the surface of Mars. New species are discovered regularly in deep ocean expeditions, from giant squid with eyes the size of dinner plates to fish that live at pressures that would instantly crush surface dwellers. Each deep-sea expedition typically discovers several new species, suggesting that millions of unknown creatures remain to be found. The deepest parts of the ocean may harbor life forms that challenge our understanding of biology. Creatures living near hydrothermal vents survive in conditions of extreme temperature, pressure, and chemical composition that were once thought impossible for life. Some deep-sea bacteria live so slowly that they may be thousands of years old, representing a completely different approach to survival than anything found on land. These ancient microbes might hold clues to the earliest forms of life on Earth. Every deep ocean expedition brings back new discoveries and raises new questions about life in Earth's most extreme environments. The deep sea continues to surprise scientists with its diversity, beauty, and biological innovation, suggesting that many more wonders remain to be discovered in the vast depths that cover most of our planet. Some researchers estimate that the deep ocean may contain more species than all terrestrial environments combined, making it potentially the most biodiverse habitat on Earth. The sea's influence on human sleep. The sound of ocean waves has been used as a natural sleep aid for thousands of years. The rhythmic, consistent pattern of waves creates what sleep researchers call pink noise, a sound frequency that can help mask other noises while providing a soothing background that promotes relaxation. The frequency and rhythm of wave sounds closely match the brainwave patterns associated with deep, restful sleep. Studies have shown that listening to wave sounds can reduce the time it takes to fall asleep and improve sleep quality. Coastal populations often report better sleep quality than those living far inland, possibly due to the combination of wave sounds, sea breezes, and negative ions produced by breaking waves. These negative ions may help increase serotonin levels, promoting feelings of well-being and relaxation that support healthy sleep patterns. The negative ions in ocean air are created when water molecules are broken apart by wave action, releasing charged particles that may have beneficial effects on human physiology. Even recordings of ocean sounds can provide sleep benefits, though many people find that the subtle variations and three-dimensional quality of real wave sounds are more effective than artificial reproductions. The ocean's lullaby has been soothing human sleep for as long as people have lived near shores, creating a deep association between the sound of waves and peaceful rest. Modern sleep clinics often use wave sounds as part of their therapy programs, and many sleep apps feature ocean recordings as their most popular option. Underwater canyons deeper than the Grand Canyon, carved into the continental shelves around the world, are underwater canyons that dwarf their terrestrial counterparts. The Monterey Canyon off the coast of California descends more than 10,000 feet below sea level, making it deeper than the Grand Canyon. These submarine canyons were carved by underwater currents, and turbidity flows over millions of years, creating dramatic underwater landscapes that remain largely unexplored. Some underwater canyons are so large they could swallow entire mountain ranges. These canyons serve as highways for deep ocean currents, channeling cold, nutrient-rich water up from the depths towards surface waters. This upwelling supports rich marine ecosystems, creating underwater oases where deep sea and shallow water species mix. Many marine mammals, including whales and dolphins, use these canyon systems as migration routes and feeding areas. The upwelling currents in submarine canyons create some of the most productive feeding areas in the ocean. The walls of these underwater canyons often support unique communities of deep-sea corals and sponges, creating vertical ecosystems that extend from the surface waters down to the abyssal depths. These canyon environments demonstrate the ocean's ability to create diverse habitats through geological processes that operate over vast timescales. Many submarine canyons remain completely unexplored, representing some of the last unknown frontiers on Earth. The ocean's memory of volcanic eruptions. The ocean floor preserves evidence of every major volcanic eruption in Earth's history, with ash layers from ancient eruptions creating distinct bands in deep-sea sediments. These volcanic ash deposits serve as time markers that help scientists correlate events around the globe and understand how volcanic activity has affected global climate over geological time. Some ash layers from massive eruptions can be traced across entire ocean basins, providing precise dates for major geological events. Some underwater volcanic eruptions create temporary islands that emerge from the sea, only to be worn away by waves over time. The Hawaiian island chain was created by volcanic activity as the Pacific Plate moved over a hotspot in the Earth's mantle, creating a chain of islands that tells the story of both volcanic processes and plate tectonics. New underwater volcanoes are still forming along this chain, gradually building what will become future islands. Active underwater volcanoes continue to shape the ocean floor today, creating new seafloor and providing the heat and chemicals that support deep-sea vent communities. These volcanic processes remind us that the ocean floor is not a static environment but a dynamic system constantly being renewed and reshaped by geological forces. Some underwater eruptions are so powerful they can be detected by sensors thousands of miles away, demonstrating the enormous forces at work beneath the waves. The sea's role in carbon storage. Ocean plays a crucial role in regulating Earth's climate by absorbing and storing carbon dioxide from the atmosphere. Seawater naturally absorbs carbon dioxide, which then becomes part of the marine carbon cycle. Phytoplankton use this dissolved carbon dioxide for photosynthesis, converting it into organic compounds that form the base of marine food webs. The ocean has absorbed about 1/3 of all the carbon dioxide released by human activities since the Industrial Revolution, when marine organisms die. Some of their carbon-rich remains sink to the deep ocean floor, effectively removing carbon from the atmosphere for thousands of years. This biological pump helps regulate atmospheric CO2 levels and has been operating for billions of years, making the ocean one of Earth's most important carbon reservoirs. Without this oceanic carbon storage, atmospheric CO2 levels would be much higher than they are today. The ocean's ability to absorb carbon dioxide helps moderate climate change, but this process also makes seawater more acidic, which can affect marine life. The delicate balance between carbon absorption and ocean chemistry demonstrates the complex relationships between ocean processes and global climate systems. As the ocean becomes more acidic, some marine organisms find it harder to build shells and skeletons, potentially disrupting entire marine ecosystems. Seasonal ocean color changes. The ocean changes color with the seasons, as microscopic marine life responds to changing light, temperature, and nutrient conditions. During spring blooms, vast areas of ocean can turn green or brown as phytoplankton populations explode, creating patches of color that can be seen from space. These seasonal changes create underwater weather patterns that affect marine life throughout the food chain. Satellite images show these color changes spreading across ocean basins like slow-motion weather systems. In tropical waters, seasonal changes are more subtle but still significant. Coral reefs may show different colors as their symbiotic algae respond to changing water conditions, while fish migrations create moving patterns of life that flow through the ocean like living currents. Even the deep ocean shows seasonal variations as surface changes eventually affect deeper waters through the slow mixing of ocean layers. The timing and intensity of these seasonal changes vary from year to year, creating natural rhythms that marine life has adapted to over evolutionary time. These cycles connect the ocean to astronomical patterns, the Earth's orbit around the Sun, the tilt of the planet's axis, and the changing angles of sunlight that drive seasonal patterns across the globe. Marine organisms use these predictable seasonal changes as cues for reproduction, migration, and other important life activities. The deep ocean's eternal winter in the deep ocean. Far below the reach of sunlight, temperatures remain near freezing year-round, creating conditions of eternal winter that have persisted for millions of years. This cold, stable environment has allowed some deep-sea organisms to evolve extremely slow metabolisms, with some bacteria and other microorganisms that may live for thousands of years. The deep ocean represents one of the most stable environments on Earth, with temperatures, pressures, and chemical conditions that remain virtually constant over geological time. The consistent cold of the deep ocean creates unique challenges for life, but also provides stability that shallow water environments lack. Deep-sea creatures don't have to adapt to seasonal temperature changes or daily warming and cooling cycles. Instead, they've evolved to thrive in conditions that remain constant across geological timescales. This stability has allowed some deep-sea species to remain virtually unchanged for millions of years. This deep ocean cold is actually crucial for global ocean circulation. As cold, dense water sinks at the poles and drives the deep water currents that circulate throughout the world's oceans, the eternal winter of the depths powers the ocean's circulation system, demonstrating how even extreme conditions play essential roles in planetary systems. Without the cold depths, the ocean's circulation would shut down, dramatically altering Earth's climate. Marine sanctuaries, underwater national parks around the world. Marine protected areas serve as underwater national parks, preserving ocean ecosystems in their natural state. These marine sanctuaries provide refuges where fish can reproduce without fishing pressure. Corals can grow without disturbance, and marine ecosystems can function according to their natural rhythms. Marine sanctuaries protect some of the most pristine and diverse ocean environments remaining on Earth. Many marine sanctuaries protect unique underwater features like deep sea, coral gardens, or critical habitats for endangered species. The Papanomakokia Marine National Monument in Hawaii protects more than 140,000 square miles of ocean, creating one of the largest protected areas on Earth. This sanctuary protects everything from shallow coral reefs to deep-sea habitats, preserving entire ocean ecosystems for future generations. These protected areas often show remarkable recovery of marine life once human. Pressures are reduced, fish populations increase, coral reefs recover from damage, and entire ecosystems can return to more natural states. Marine sanctuaries provide hope that even damaged ocean areas can heal when given the opportunity. Some marine sanctuaries have been so successful that they've become models for ocean conservation around the world. The ocean's role in human history. The ocean has shaped human history and culture in profound ways, serving as both barrier and highway for human migration and trade. Early seafaring cultures developed sophisticated navigation techniques, reading ocean currents, wave patterns, and celestial signs to traverse vast distances with remarkable accuracy. The ocean connected distant civilizations while also preserving their isolation, creating the rich diversity of human cultures we see today. The Polynesian navigators who settled the Pacific Islands used their knowledge of ocean conditions to make voyages of thousands of miles in outrigger canoes, finding small islands in the vast Pacific using techniques passed down through generations. Their understanding of ocean patterns allowed them to populate remote islands across 1/3 of the Earth's surface. These navigators could read wave patterns reflected off distant islands, use the flight patterns of seabirds to locate land, and navigate by star positions with incredible precision. Ocean currents influence the development of trade routes and the spread of cultures around the world. The Gulf Stream helped speed sailing ships from Europe to North America, while trade winds in the Pacific and Atlantic shaped the development of global commerce. The ocean connected distant civilizations while also preserving their isolation, creating the rich diversity of human cultures we see today. Many of the world's great cities developed at natural harbors, where ocean currents and geography created ideal conditions for maritime trade. The sea's hidden waterfalls within the ocean itself flow invisible waterfalls where dense, cold water cascades over underwater cliffs and into deeper basins. These underwater waterfalls can be thousands of times larger than any terrestrial waterfall, moving vast volumes of water in slow-motion cascades that continue for thousands of years. The largest underwater waterfall, located between Greenland and Iceland, carries 175 million cubic feet of water per second, equivalent to about 2,000. Niagara Falls, the Denmark Strait Cataract, flowing between Greenland and Iceland, carries 175 million cubic feet of water per second, equivalent to about 2,000. Niagara Falls. This underwater waterfall is created by dense, cold Arctic water sinking beneath warmer Atlantic water, creating a permanent cascade that helps drive global ocean circulation. The waterfall drops more than 11,000 feet, making it more than 3 times taller than Angel Falls, the world's highest terrestrial waterfall. These hidden waterfalls demonstrate the ocean's three-dimensional nature, where water masses of different densities create vertical structure just as dramatic as any landscape feature on land. They remind us that the ocean is not simply a flat surface, but a complex, layered environment with its own mountains, valleys, and falling water. These underwater waterfalls play crucial roles in global ocean circulation, helping to drive the currents that distribute heat and nutrients around the world. The eternal ocean, our planet's heart, as we reach the end of our journey through the sea's gentle mysteries. Let your mind drift like a piece of driftwood on calm waters. We have explored depths that have never known sunlight and surfaces that dance with bioluminescent stars. We have followed currents that connect every drop of water on Earth and listened to whale songs that carry across entire ocean basins. We have discovered that the ocean is far more than just water. It is a living system that breathes, circulates, and nurtures life in ways that connect every part of our planet. The ocean is ancient beyond our comprehension, yet it renews itself with every tide, every wave, every breath of water vapor rising to become clouds. It is vast enough to humble us, yet gentle enough to lull us to sleep with its rhythmic breathing. Every fact we've shared tonight is part of a greater truth, that the sea connects us all, carrying our dreams across its waters, just as it has carried life itself for billions of years. The ocean holds the memory of our planet's entire history while constantly creating the conditions that make life possible, from the microscopic phytoplankton that produce the oxygen we breathe to the massive currents that regulate our climate. The ocean operates as Earth's life support system. It is the planet's circulatory system, its thermostat, its chemical processor, and its nursery for life. The sea connects every continent, every climate, and every living thing through cycles of evaporation and precipitation, currents and tides, migration and reproduction that have operated for billions of years. As you settle into sleep tonight, remember that the ocean is still out there, breathing its patient breath, circulating its life-giving waters. and continuing the ancient rhythms that have sustained our planet since the beginning of time. Let its constancy comfort you, its mysteries intrigue you, and its gentle sounds carry you into peaceful dreams. The waves will still be whispering against shores around the world when you wake, continuing their eternal conversation between sea and land, between depth and surface, between mystery and discovery. In your dreams tonight, perhaps you'll find yourself floating in warm, clear waters, surrounded by the gentle glow of bioluminescent creatures and lulled by the distant songs of whales. Perhaps you'll drift along ancient currents that have carried countless generations of marine life on their journeys across the blue planet. Or perhaps you'll simply rest in the knowledge that you are part of this vast, interconnected water world that covers our Earth like a gentle blue blanket. The ocean teaches us patience through its slow, deep currents that take centuries to complete their journeys. It teaches us resilience through its ability to weather every storm and heal from every disturbance. It teaches us connection through the countless ways it links every part of our planet through water, weather, and the flow of life itself. Most of all, it teaches us wonder, reminding us that even in our age of exploration and discovery, our world still holds mysteries as deep as the ocean itself. Sleep well, knowing that you are part of this vast, gentle, endlessly fascinating water world that covers our blue planet. The sea's ancient lullaby continues through the night, its waves carrying the dreams of every creature that has ever lived near its shores. Tomorrow will bring new tides, new currents, and new discoveries, but tonight belongs to rest, carried on the eternal rhythm of the ocean's breathing. If you've enjoyed this peaceful journey into the ocean's secrets, consider subscribing to join us for more gentle explorations of the natural world. Share your thoughts in the comments about which ocean mystery captured your imagination most, or tell us about your own peaceful encounters with the sea. Your stories help build our community of dreamers and ocean lovers, one sleepy soul at a time. But for now, let your breathing slow to match the rhythm of distant waves. Let your body rest like a shell settled into soft sand. Let your mind drift with the gentle currents that flow through warm, peaceful waters. The sea's lullaby continues, and your dreams are about to begin. Close your eyes and let the ocean carry you into the deepest, most peaceful sleep, surrounded by the gentle embrace of the eternal sea. Good night, and may your dreams be filled with the wonder and peace of the ocean's endless mysteries.